So how does the Blitzy platform actually work?
It works just like traditional, typical software development processes work at the enterprise, which are the best at making software. So you start right at the beginning with a description of what you'd like to build, which is if you're starting from scratch. The platform takes your description and translates that into a PRD, a product requirements document that everyone is used to working with. And that lists down all of the software requirements that your app needs to solve for. It lists down the functional requirements, the non-functional requirements, everything that a good product manager would include. And in a way, this is the opportunity to loop in the product managers in your team, should you have them, and have them review and sign off on what the product should be. Once you approve the product requirements document, you would move on to the next step and build the technical requirements document, the technical specification, as we call it. And that's a chance for the software architects to come in and absorb the requirements and sign off. So that requirements document is generated completely autonomously by our platform, and it's reviewed and approved by humans, saving you weeks of work in that process, if not months. And once you've approved both those documents and you have buy-in from the team, you hit build, and the platform autonomously generates all the code for you. And the way it works is we leverage system to AI. We have thousands of agents coordinating and cooperating, working to solve every single requirement that you've listed and approved using our AI. And we generate a code that is hosted in the GitHub repo connected to your private account. And from there on, your engineers can complete the last mile. So with this autonomous process, you now have gone from a description to a functional product.
And so I think folks can easily conceptualize the requirements creation, the tech spec creation. This is, not huge inference workloads to get this done. But when they click build on the tech spec to finally build this into the repo, they're waiting 8 to 12 hours. So they're calling it a day. And so what is happening? Let's say it's a big project, it's a 12-hour. What is actually happening? And then what is the output more prescriptively? What are the folders and files when they show up to work the next day?
Yeah, absolutely. So that's a great question. When you sign off on that technical specification, it's about 12 pages at this point, right? If you're building an enterprise-grade product. And it's about 100,000 lines of code around that ballpark. So that's a sweet spot for our platform. Now, this is too large for any AI model out there, right? So the typical input context window is 200,000 tokens, which is decent, but the output token limit is between 8,000 to 16,000 tokens, depending on which model provider you use. And the best output you can get from any single model with that output token limit is about 800 lines of code. So how do you get it to generate 100,000 lines of code, right? So that's the core problem that the Blitzy platform has solved. And the way we do it is that we recruit multiple agents dynamically based on the complexity and based on the level of detail that you have in your technical specification. And it takes us 10 hours of thinking. So if it's a 12-hour run, depending on the complexity of the project, not every project is 12 hours. Some project could be built in 4 hours, some projects more than 12 hours. But about 80 to 90% of that inference time is thinking. And when we are thinking, we try to address every single requirement that you've listed in the technical specification. We have our own format for that technical specification that we will give you from scratch. So you can use that if that's what you prefer. But you can also edit the sections of the document and have your own information out there. It's a white paper for you. You can do whatever you want with it. And then once we've spent all the time thinking and making sure we've addressed all of your requirements, you have this code repository, and it has, of course, all of your code categorized by different folders. We try to use a microservices-based architecture by default, so unless you specify differently, because it helps us organize your modules into folders. Like, for example, you have backend, web, maybe you have an iOS or Android app, so you have dedicated folders for all of that. And it's a monorepo with microservices architecture at that point. And we have a documentation folder. We have, within that documentation folder, we have the input prompt you gave us, the software requirements spec, the technical specification, and we have a document that lists down the human tasks that you would need to do to complete this project. So we claim to build 80% or more of your project, and this document right at the top gives our estimate of how much we think we built, right? And what's remaining is typically configuration items. There could be bugs, there could be runtime issues, but we do our best to identify that and assign those tasks specifically for the humans, so they're not working with some random piece of code that they don't understand. We try to be as descriptive and as specific as possible of what it would take to take this code from the state that it is in to production. And from the code standpoint, we do our best to account for the best standards in terms of code quality, in terms of style, in terms of security, making sure all the right boxes are ticked for authentication, for defensive coding, so that you don't have to go through a massive rewrite of what the AI has given you. The code is ready to go. You can use it as is, and it's best in class in terms of coding standards. But what's even more helpful is every file that contains code has a commented list of human tasks. So you have this global document, as I mentioned, in the documentation folder, and you also have in code, in context comments of what human developers need to do to finish the project. And that's a comprehensive output that is essentially as close as possible as you can get overnight to a finished product.
And what should folks expect around the quality of the code? I think folks hear, okay, you solved the output limit problem. You can grade 100,000 lines of code. You're telling me it's following my requirements. But what are some expectations that folks should understand? Because I think folks are typically shocked at how precise and good it is. Maybe
Yes.
you could provide some expectations around that.
Yes, so there are a bunch of languages and programming platforms that we fully support natively. And I would describe those at the moment as TypeScript, Python. We have a work stream ongoing for Java, for PHP, for .NET, which will be C#. So for those languages that we support natively, we are able to guarantee that there won't be any circular dependencies. There won't be any bugs in the code because we actually compile your code and make sure that it's ready to go. So this is unlike something you would do with the other AI tools out there, the copilots, where it would give you some code, you would get an error when you try to compile it, and then you go back to the model, it would maybe give you another revision of code, and then you would spend hours doing this until you have a finished product. But by the time you have the finished product, it no longer solves for the original requirement that you had, right? And then it's a cycle again for you to fix the runtime issues. You only fix the compile time issues so far. So it's an endless loop that sometimes actually takes longer than it would otherwise take you to go from scratch if you're building a small project. But for large projects, it's a no-brainer. You cannot use that process. So the Blitzy platform solves that for you. So the number one expectation you can have is that if it's a language we support natively today, you're going to get really high quality code that hopefully combines out of the box. If it does not, there could be less than 10 compile time errors, maybe TypeScript issues or the kinds of import errors that you need to fix. After you do that, there could be, in our experience, we've rarely seen runtime issues, but there could be runtime issues. There could be formatting style issues. But all of these are minor issues that a human developer can fix in a day. Our goal is that when you get a Blitzy generated repo, a human developer, that is ideally a junior level developer, can fix all of the issues and get your code running in one day. And the changes that they're making are, fixing minor bugs, doing style upgrades that maybe the model missed. And it's a really fast way to get this built quickly because, if it's a simple project, you might as well build it yourself. But if this project is 100,000 lines of code, there's no way you're going to build it maybe even in a few months. So this platform gets you the way there. You fix the last mile issues, you have a running product.
And that really describes our new product work stream, which is very easy to walk through, but we've seen the most excitement around our ability to work with folks' existing products, their existing code bases, and build on top of that. So can you walk through that workflow for us?
Yes. So the new product work stream with Blitzy is where we connect to your GitHub and we create a new GitHub repository out of scratch. It could be GitHub, GitLab, you pick. The existing product work stream, which is where, as you rightfully mentioned, most of our customers fit in, is where you already have this code base. It could be, hundreds of thousands of lines of code. It could be up to 1 million lines of code. That's completely fine. And
it could be multi-repo.
Yeah. It could be multi-repo.
Yep, usually is.
Right, it usually is. Not everyone likes the monolithic philosophy. But we try to structure what we can for our end users, but we like to meet our users where they are. So we don't enforce a philosophy, let it be, in terms of coding style, let it be in terms of architecture, design. It's completely up to the humans. The humans are in control. So we can connect to your repos using the GitHub integration, and you can pick which GitHub repos you want to add to a particular project. A project is the smallest unit of work that we organize, code by within our platform. So a project is essentially a net new task that you want the platform to solve. So if you have a particular product that spans 5 different repos, and you want to add a new feature that uses a backend API and has a UI, and both of these exist in different repos, and that's a good example of a project. You can connect your backend and front-end repos, and then you can as soon as you do that, you can elect to generate documents for those repos, and our agents will crawl all of your files and understand what the project is doing. And your code doesn't even have to be clean. We have the ability to read your code and still make a very educated guess of what it is doing. And it's not a guess, because we're literally analyzing your code, and AI has seen code like that, a lot of it. So it's quite good at this. You could try any AI chatbot and it'll be able to do this well for you. But we've perfected that process. So we're able to generate documentation for your code that you may or may not have. And now you can use that document as the interface to add new features. So the UI feature that I mentioned, you would look up the software requirement specifications, or the PRD as we like to call it. You would add your new feature. It would generate the technical document for you. You would review and approve that. And from then on, the AI agents that we have on our end would add that feature to your code, but you're still in control. So when we add features, we will create pull requests in GitHub or merge requests in GitLab, and you would be approving those to merge them into your product. So you submit that request. We take time to build it. It may not always take 12 hours in this case, because if it's a simple feature, it may be like 3 or 4 hours. You get notified once you have a pull request. You approve the pull request, and you can test it. If you don't like what we built, you can reverse the commit and go back to your original state. So this is a nice way where you can leverage AI to do most of the work for you, and you still retain control.
And folks think of this workflow really as a way to get, as a starting point, perfect documentation, take their roadmap, and then aggressively build towards that roadmap, 4 or 5 times faster than they otherwise would.
Yes.
Since we're building up against, probably 80% on even for the add feature workflow. We've seen a really exciting emerging category that we've been able to support with this existing product workflow for folks, which has been refactoring, which fundamentally works the same way, the same flow, but is otherwise costing enterprises a lot of time and money. So maybe you could talk about the refactor use case as folks bring their code onto the platform.
Yeah, that's a great place to talk about. So refactoring is a common use case. There are reasons why you need to refactor. One is that the industry is clearly moving faster than you can keep up. Like if I were to count how many JavaScript frameworks out there, I'm pretty sure I'll get it wrong. Every other month, there was a time you used to hear of new JavaScript frameworks. But JavaScript, I would say, is relatively easy. When you go into the more hardcore languages like Java, and if you go all the way back even to Fortran, those languages are now, in case of Fortran at least, quite out of date. If you're on Java 5 or Spring Boot 2 and you want to go to Java 6 and Spring Boot 3, again, that's a hard problem, because you're going to have to take resources out of the live products and assign them to this task, which is otherwise complex. It's not interesting, and it doesn't really add much to your bottom line. But as you keep postponing this task, you're increasing your tech debt.
Yeah.
And that is what typically we've seen happen with all these large enterprises. So, but now, because we support, autonomous development, you can bring your existing repo that needs a refactor to our platform, connect the repository, set it to the task of refactor. Like, for example, you want to convert to a later version of Java, and we'll crawl every single file and push a new pull request that upgrades your project to the latest version of Java. So your technical resources, rather than writing everything, can just focus on approving, compiling, and testing if everything works the way it should, rather than having to go through this painful process of trying to understand, how the project works. Because chances are, as you've built this project over many years, most of your co-developers that actually stood up the project have churned, and hardly anyone knows what the project does. So even if you run the first step, which is generating documentation by connecting that repository to our platform, you now have an understanding of what the code is actually doing, and that by itself is super valuable to a developer. Having worn the developer's hat for so long, I can attest to that. where I can now make sense of what the code is actually doing without spending hours trying to understand and figure things out. So you can do that as a first step, get the documentation, run the job to refactor everything, approve the code, and that's it. Within a matter of days, you've now eliminated tech debt that has been accumulating for years and that would have costed you months of the whole team's effort to get done.
So how should folks think about this new paradigm we're in, which is autonomous development, right? Batch building large amounts of software precisely, 80% or more in our situation. When they think about bringing something like this into their organization, like how does one, maybe the CTO or VPE, really think about this strategically?
Yeah, so that's a great question. So, if you think about the traditional way of developing things, it was human-led, AI supported, right? And you had co-pilots. There's research out there. It started with saying that co-pilots make you 40% more effective. It then grew to 50%, but then there was another study that I think was done by Harvard or someone that learned that if you pair a senior developer with a co-pilot, you actually make them worse and they're less productive just because the code isn't as high quality. The point being, humans and AI, they think at different levels and they have different skill sets. They have very vastly different levels of context. And if you pair them to work together at the same speed, you're limiting the other side. Because if you unleash AI, it can think at a capacity and a level that is greater than humans, even though it may not have the raw skill and the broader context that humans have. So what we've done is we flipped this paradigm. We're AI-led and human-supported. And if you think of it philosophically, much of the patterns that you follow to build software, be it best practice security, be it high quality, be it scalability, robustness, reliability, high availability, all of these paradigms have been very well documented. And the models have seen it. They've seen code that follows those practices. They've seen code that does not do it, right? So what we managed to do is isolate and have AI to focus on the best parts of those best practices and always follow the instructions that the humans give them and generate high quality code. So from a senior engineer standpoint, it's as if you got this army of, instead of 12 junior engineers, you now have 3,000 AI agents that can do exactly what you described, that are not going to take a break, that don't need your guidance and hand holding to get them up to speed. So you can focus on doing the most critical parts, right? And they can do all of this repetitive work for you. They can build most of the project, and you have the final seal of approval to decide if the code makes the cut or not. And if you're a VP of enterprise software or a senior leader, the way you can understand this is the parts that are most important to you can be assigned to the humans, and they can always have control over it. The parts that are repetitive, and that applies to every single project, can be assigned to AI, and we support that. So in the technical specification that you give us, you can ask us for skeletons if you'd like the AI to not even think about certain parts. You can ask AI to take a shot at it and then let the humans decide what you want to do with the rest. You can simply break up the project the way you want. So long as you can describe it, we can build it. That's our tagline: you describe it, we build it. And this is a great way to accelerate your roadmap. So what would otherwise take months of scoping followed by years of building, you can now build within days.
I think that's what I've been most excited by. Is there's really two approaches for how the world shapes out. There's, all right, we're going to need less people, and we're going to need a lot more software. And everybody that we've chatted with about integrating Blitzy, or folks that are already using it, are just building more software, because there's almost an insatiable appetite within the organization to have better consumer-facing experiences, to have better internal software, to have better processes within in between teams. And so the rate in turn of software as an output has just increased dramatically, and that's what's driving the bottom line down, not this reduction in force. So it's very exciting for us, because that's the world that we believe in, and to see that actually materialize with our customers is very awesome.
Yes, and as we talk about these factors, sometimes enterprises have a looming concern in their head. My code is my IP. How do I trust you? So I'd like to add a few pointers towards that. One is that we are fully SOC 2 compliant. We're pursuing that at the moment, and we expect to be compliant by the time we're live.
This video comes out, yeah.
This video, yes. The second thing is, if you're on the enterprise plan, we don't train our models on your code. Your code is your IP, and we highly value and respect that. Coming from a software background ourselves, we don't even store your code. So we work just like how the other platforms work. There's Cursor, there's GitHub Copilot. We store embeddings of your code which, if you were to take those embeddings, you cannot make any sense of them. There's no leak there. There's no risk there. It's just what an encoded version of your code that can never be decoded, right? So that's what we work off, and your code is safe. It's in your premises. We work in, cloud-based, hybrid, VPC-based. We can meet you where you are, and we understand what it takes to, protect your IP, and we take security very seriously.
Yeah, it's a super exciting time, and I'm happy that we made this video so that we can show folks a little bit behind the scenes on how it works. And for more on that, you can always chat with us.
Yeah.